Tokyo in July and August now pushes past the mid-30s, with heavy humidity and an urban heat island trapping the heat. In recent summers, heat waves have sent tens of thousands of people to hospital and killed more than 100 in a single season. In some parts of Tokyo, you can find pockets that feel noticeably cooler in August, while the streets nearby still feel like a grill plate. Japan is drowning in air conditioners, and somehow the cities are still getting hotter, not cooler. Every unit throws its heat back outside. The more it cools the inside, the more it warms the street. So instead of just building more AC, engineers started asking a different question. How do you cool the city underneath the air conditioner? Today, we're counting down 8 ways Japan is quietly cooling its streets, buildings, and people. From a centuries-old water ritual to a rooftop film that throws heat into space, and a cooling device you can literally wear on your own body at number 1. If you care how cities survive summers like this, stick around and maybe hit subscribe so you don't miss what comes next. Japan is one of the most AC-dependent societies on the planet. So this isn't a story about a country that doesn't need air conditioning. It's about a second cooling layer under the air conditioner. Street rituals, wind paths, cool roofs, shared chillers, and gadgets you wear on your skin, all working to keep the heat from ever fully winning. The first layer of that story starts with something you can do with a bucket of water on your doorstep. Number 1. Uchimizu plus dry mist systems. On a summer evening in Tokyo, shopkeepers step outside with buckets and pour water across the stone in front of their stores. This old habit is called Uchimizu, sprinkling water on the ground in front of homes and shops to cool the air. And its modern cousin is the dry mist cooling system, using pumps and nozzles instead of buckets. When water evaporates, it steals heat from the ground and the air. With Uchimizu, the water sinks into the surface, then evaporates and pulls heat out of the stone. With dry mist, droplets are so fine they evaporate before they hit the pavement, dragging heat out of the air. Measurements in Japan have found that simple sprinkling can pull near-ground temperatures down by several degrees and lower the air at head height by up to around 1.5 degrees, while dry mist systems can drop local air temperature by around 2 to 3 degrees within minutes of switching on. Here's the catch though. In very humid air, or once the wind picks up, evaporation slows and the effect shrinks. Past a light breeze, the cooling can almost vanish. And since this works by spending water, cities have to be careful when and where they use it, leaning on recycled or rainwater. Even so, it's where Japan's second cooling layer begins, a ritual you can do with a bucket, and a mist you can walk straight through without getting wet, both taking the edge off the street before the heat fully builds. The next idea doesn't touch water at all. It reshapes the wind itself, so an entire city can breathe. Number 2. Kaze no michi / wind paths. On some Japanese coastal city maps, you'll see long, straight bands of parks, rivers, and low-rise blocks cutting in from the sea. Urban planners call them kaze no michi, wind paths. Hot air over the city rises and leaves a low-pressure pocket behind it. Cooler air over the water wants to rush in to fill the gap. If the coastline is walled off with towers, the breeze stalls. Line up open spaces, parks, rivers, wide streets, low buildings, and you give the wind a highway straight from the bay to the neighborhoods that need relief. Areas along these wind paths can feel a few degrees cooler than the blocks just outside the corridor, and nighttime temperatures fall faster when the breeze has a clear route to sweep stored heat away. The catch is that a wind path only works if you keep it open, drop a tower in the wrong spot, and the breeze gets choked off. And it's far easier to build a corridor into a brand new district than to carve one back into an old one. But airflow outside is only half the battle. The next idea reaches back 1,000 years to redesign the air inside the building itself. Number 3. Machiya passive architecture. If a wooden house from centuries ago can stay cool without air conditioning, why did we stop building them? Step into an old wooden townhouse in the middle of a Kyoto summer, and your body notices the cool before your brain does. These long, narrow houses are called Machiya. They were built like wind tunnels, a narrow street frontage, a deep plan running back to a courtyard, sliding doors instead of walls, and deep eaves that shade the openings. Hot air rises and slips out near the roof, pulling cooler air in from the shaded courtyard, so the whole house breathes front to back without a fan. Measurements in traditional Machiya have found indoor temperatures several degrees cooler than the air outside at the height of summer. Modern architects scale up the same logic instead of abandoning it. In one Kyoto renovation, a skylight was added above the original courtyard, so the two act as a single ventilation shaft. Hot air escapes up top, while the courtyard draws cool air in low, exactly the way the old Machiya breathed, now with modern insulation. Now the honest part. You can't drop a 200-year-old wooden house into a dense city block. Land is expensive, fire codes are strict, and people expect sealed, quiet rooms. So Machiya principles usually get blended into modern buildings rather than replacing AC outright. Even so, every degree the building sheds on its own is a degree the machines never have to work for. But buildings are only half the story. The next mistake Japan is fixing is baked into the streets under your feet. Number 4. Cool pavements. Look down at the road the next time you're out on a hot day in Japan. Traditional black asphalt is one of the most heat-absorbing materials we've ever laid across our cities. It reflects little sunlight, soaks up almost everything else, then slowly leaks that heat back into the air even after the sun goes down. To fight that, Japanese cities are experimenting with cool pavements. Roads treated or rebuilt so they store less heat and shed more of it. Some use highly reflective coatings, so more of the sun's energy bounces back into the sky. Others use lighter colored aggregates or surfaces that hold a thin film of water, so the street can cool itself through evaporation after rain or a light sprinkling. Field tests in Tokyo have measured road surfaces running as much as 8 to 10 degrees cooler than ordinary asphalt under the same sun, and the air above those streets can shed its heat faster once the day cools and traffic thins out. One trade-off, worth naming: these surfaces cost roughly 30% more than standard asphalt, and you can't repave a whole city overnight. Tokyo has laid only a few hundred kilometers over nearly 2 decades, and in the wrong spot, a very bright road throws glare into drivers' eyes, so planners pick sites carefully and often pair reflectivity with water-retentive designs rather than painting everything white. Even so, every degree the road refuses to store is a degree that never reaches the air in the first place, and the ground is just the start. The next idea cools entire buildings with a thin film that quietly throws their heat into space. Number 5. SPACECOOL, radiative cooling. On an Osaka rooftop, under full midsummer sun, there's a strip of what looks like an ordinary white film laid over metal sheets. Touch it at noon. The air is scorching. The bare roof beside it is hot enough to burn your hand. Yet this strip is cooler than the air itself. It's called SPACECOOL, a Japanese radiative cooling film that makes a surface colder than the surrounding air in direct sunlight, using no electricity. It's tuned to emit its heat in a narrow band of infrared wavelengths that slip straight through the atmosphere, the atmospheric window. So the heat ends up in deep space instead of lingering on the roof. In tests, SPACECOOL has kept surfaces roughly 2 to 6 degrees below the surrounding air in direct sun, and on container-like structures, it cut air conditioning energy use by close to 30%. To be straight with you, the effect is strongest under clear skies. Clouds, haze, or pollution eat into the cooling window, and like any new material, it costs money. So for now, it shows up on selected rooftops and equipment, not across a whole city. But a roof that quietly dumps its heat into space all day keeps the rooms below from turning into ovens before the AC ever switches on. The next step is bigger. What if you could cool an entire business district from a single machine hidden deep underground? Number 6. District cooling techniques. Dense Japanese business district. Towers, malls, and offices crowd together. On a summer afternoon, each building would normally run its own compressors, all fighting the same heat. But here, they don't. Instead, a single plant under the streets makes chilled water on an industrial scale and pipes it through insulated tunnels into each basement, where it absorbs heat and circles back to be cooled again. This is district cooling. One cold source shared by the whole district. Large machines running at steady load are far more efficient than thousands of small ones ramping up and down, and a central plant can use high-efficiency chillers, heat pumps, and thermal storage, shifting work to cooler nighttime hours and flattening demand on the grid. In places like Tokyo Skytree Town, these systems have cut primary energy use by around 40% and CO2 emissions by roughly half compared to each building running its own equipment. The limitation is real. This only pays off in very dense districts with big, steady cooling demand, and the plant and trenches cost a fortune to build. So district cooling lands in a handful of specific hubs, not out in the suburbs. Even so, it's one of the most powerful pieces of the second layer. Instead of 10,000 separate battles against the heat, one optimized system carries a whole cluster of buildings. But all of this, the mist, the wind paths, the passive houses, the cool pavements, the underground plants, still misses one thing. What if you could grow shade on the side of your building and eat it at the same time? Number 7. Green curtains and rooftop greening. On a summer morning in Nagoya or Tokyo, look up at some apartment blocks and you'll see something halfway between a garden and a curtain. The sunlight hits the plants, not the glass, and the air that drifts in feels shaded and softer than the street below. These are green curtains, living walls of climbing plants grown on nets in front of windows to shade them from the sun. Plants block and filter sunlight before it hits the wall or glass, stopping much of the heat at the building's outer skin and cooling the air around them as they breathe out moisture. Measurements in Japanese projects have found that shaded walls can be more than 10 degrees cooler than bare concrete, and rooms behind those vines can run several degrees cooler. There's an honest limitation. Plants need water, pruning, and care, and not every tenant or building manager will maintain a vertical garden all summer. Green curtains work best when whole communities, schools, or companies commit. A single balcony in a tower of bare concrete won't change a city's temperature by itself. Even so, they do something metal and concrete can't. They turn cooling into something visible, sometimes even edible. Everything so far has been about cooling spaces: the street, the wind, the building, the district. But what happens when the cooling system doesn't wait for you in a room at all, and instead wraps around your own body? Number 8. Fan jackets and wearable coolers. Walk down a Japanese street in the height of summer, and once you know what to look for, you start seeing them everywhere. These are wearable cooling systems: fan jackets, neck coolers, and devices like Sony's Rion Pocket, and they turn the idea of air conditioning inside out. Instead of cooling the room and letting your body come along for the ride, they cool your body first. Fan jackets are the simplest. Tiny battery-powered fans stitched into the coat suck in outside air and push it across your skin, turning the jacket into a moving layer of wind and boosting sweat evaporation. Devices like the Rion Pocket sit at the base of your neck, pressing a small, solid-state cooling module against the skin where blood runs close to the surface. Run current through that module, a Peltier element, and one side becomes colder, pulling heat out of your skin while a small fan blows the heat off the warm side. Tests have shown that workers wearing fan jackets in hot environments feel more comfortable at the same air temperature than those in ordinary clothing, and can keep their core body temperature in a safer range during long shifts. Neck coolers have dropped skin temperature at the contact point by several degrees, extending how long someone can stay out in the heat before it becomes dangerous. A fair note, so this stays honest. A fan jacket or neck cooler doesn't change the air around you. And if the heat is extreme and nights stay hot, they can't replace real cooling, especially for the very old, the very young, or people already ill. They need batteries, they cost money, and they work best as one more line of defense, not a magic fix. But in a country where so much daily life happens outdoors, on construction sites, delivery routes, and station platforms, putting the cooling system directly on the person might be the most quietly powerful idea we've covered today. And that's really the thread running through all 8 of these. Nobody waited for a bigger machine to solve this. Someone just asked, what if the street cooled itself? What if the wind had a road to travel? What if the roof did the AC's job for free? So let's step back and look at what all 8 of these add up to. Japan is doing something different. It's still one of the most air-conditioned societies on Earth, but it's building a second cooling layer underneath its air conditioners. At the street level, that layer is water and mist in the air, cool roads that stop the asphalt from becoming a heat battery, and wind paths that let the